All right, so thank you for watching our presentation. I am Stephen Reagan here with Vivian Doe and Mohammed Mahmoudi Ghaznavi, and we're here to talk to you about the pipeline that we put together regarding airlines information, weather information, and things related to flights generally. And here to give us an introduction to the topic, we'll start with Mohammed.
Thank you, Stephen. And why we decided to work on flights and airlines datasets for this project. We all know the airline industry plays an important role in the world's transportation sector. Many businesses and industries all around the world rely on aviation industry to connect with various parts of the world. Varied factors such as weather conditions, air traffic control, airport operations, traffic volume, worn out planes, and many other reasons are capable to affect airline services, leading to delayed flights. Understanding the effect of these issues prior-hand by predicting these delays to an extent would allow the airline operators to be better prepared for the potential reasons for the delay of the flights in advance. Optimizing services and decreasing flight delays will most likely lead to increasing customer satisfaction, which ensures continued and potentially increased profit. In this project, we are using MySQL, Python, and R as program tools in separate steps.
And in order to populate those program tools with something useful, we found some data from a project called AnyFlights. This is an open source data project that you can go check out. They get their data information from the Bureau of Transportation Statistics, a branch of the federal government. And we use their R-based API calls. And we ultimately ended up downloading something like 30 CSV files covering 4 different airports around the country, including, the airlines that are being analyzed, the actual flights that are taking off, some weather related information. And for our purposes, for practical purposes, I should say, the largest files were something like 25 megabytes in size. So it's well under the GitHub threshold for being able to share files as a team on our group GitHub, which you'll see a little bit later. And just a little bit more about the data description itself. So we had 5 files for the airlines. That is 1 file per year covering all 4 airports. And the airlines file, it's just the acronym of the airline and the name of the airline. It's just a way of linking other things together in our architecture diagram, as you'll see in a minute. We also had 5 files for flights. This is 1 file per year covering all 4 airports. And this is everything that you could possibly want to know about the flights. What date did it happen? Who is the airline? What airport did they leave from? What airport were they going to? What was the departure time? What was the minute delay or early? Did they arrive late? Did they depart late? All of that information. And then we also had weather information. So this is 1 file per airport per year. And we had both hourly and 5-minute increments of weather happening, weather as it was measured at the airport that we were analyzing. And that includes, precipitation, wind speed, wind direction, temperature, ice and snow, just everything having to do with weather at that time. And moving on to our ETL, present to Vivian, please.
Sure, and this is the general overview of our methodology. So like Stephen said, we extracted all of our data from an R package called AnyFlights. And then in terms of transformation, we did some manual pre-processing steps of the flights and the weather CSV files. And then this included just changing the date time format and also removing some of the rows that weren't necessarily relevant. And then we loaded our database onto the MySQL Workbench server. And then since we were reproducing the database on 3 separate local systems, we performed code reviews to check for consistencies. And this includes running the auditing and monitoring scripts, as well as making sure that each table has the correct number of records. And then this is our architectural diagram. Like Stephen mentioned again, each year we have 6 types of tables. The first one is sort of a dictionary list with the 2-letter code for the carrier and then the name of the airlines, and this is the airlines table. We also have the flights record for the year, and then for each airport we have the weather table. And then this diagram only shows a relationship for 1 year for 2018, but this can be used as a reference for the other 4 years.
Data pipelines are created to serve both analytical and operational purposes. Travelers, as one of the main assets in this industry, could benefit from curated information on flight delays. Different delay parameters, such as average arrival and departure delays, could be useful for airlines to minimize the inconvenience caused by flight delays. Daily and monthly aggregates of precipitation and flight delays are beneficial for airports to manage their air traffic. Now let's dive into them separately. Data pipelines done right have incredibly advantages for airlines. Data engineers cannot wait for a static report, which are outcomes of these pipelines, to provide the real-time insights to properly guide airline companies to improve their performances. Data engineers will have access to information such as what is monthly and yearly average delay? What is the average delay for each carrier? What flights had delays over average delay time? Total delays based on the same destination. Schedule total flights with their delay based on the time of the flight for each origin separately. And last but not least, the impact of unexpected occurrences on airlines could get analyzed by data scientists. For example, COVID-19 has brought the air transportation sector to a standstill. As we can see in this graph, performed departures from John F. Kennedy Airport decreased dramatically in May 2020 compared to previous month. One of the pipeline outcome compares the flight information before and during pandemic. As an example, as shown in tables, JetBlue carrier flight numbers from John F. Kennedy Airport dropped by 86%. The analysis is extensible to monthly, seasonal, and even yearly. Our study can provide information for other airports as well.
A separate and second pipeline that we created is curated information for travelers, because what's important for airlines isn't necessarily important for the average consumers. Example outputs include holiday delays for people who are visiting friends and family, possibly during Thanksgiving or Christmas. It also includes a list of destinations from an airport that is useful for trip planning, as well as general flight information for anyone who wants to sign up for loyalty rewards program. The graph here shows the yearly departures from Houston, Texas by airline in 2018. So for example, let's say that I'm a business woman based in Houston, Texas, and I want to sign up for a loyalty rewards program, so I can get points for all of the flights that I will be taking from IAH. So from the graph, we can see that United, ExpressJet, or even Mesa Airlines could be potentially good options since they had the most flight count. However, when we look at delay, we see that United, even though it has over 6,000 flights, the average delay is over 13 minutes compared to ExpressJet, which only has a delay of 3 minutes. So depending on which one I prioritize more, I would choose an airline based on that. And then this is useful for anyone who is interested in the rewards program or anything else related to business or trip planning.
And so that is a pipeline for travelers, and Mohammed talked about a pipeline for the airlines themselves. Another third possibility is data pipelines for airport consumption, such as understanding the weather-related impacts on flights, flight delays that are caused by, heavy congestion and things like that. And so this will be another pipeline that we created or sub-pipeline, whatever the phrase is, to address those types of questions for airports. And this is really for the nerds here, so let's just dive into it. In order to wrangle this information together that we all did in our SQL scripts for our ETL process, we categorized the number of daily delays in a number of ways. We had to aggregate them somehow. Weather data comes in 5-minute increments, so we had to create a daily date variable for those. We had to aggregate those by the hour, by the day, and so on. We had to take the peak max temperature, and this is an example of one of the views that we created in order to address those types of questions for the airports themselves. And if I jump over here to the GitHub repository that we created housing this project, if you want to follow along at home, just follow these steps. Here are the contents. You can set up the database yourself. You can monitor the database to make sure that it's working properly and run the outputs that we had created for you. If you want to just, cheat and take a look at the Python outputs and the notebooks that we created without actually running them for yourselves, if you just want to look at the stuff, you can see here we connect to MySQL Server with this nice bit of code. And then just the outputs themselves, don't require a lot of manipulation. So these are the daily flights over time. Here's one of the images that you saw in Mohammed's pipeline output. So this is, you see that daily flights from JFK Airport just fell off a cliff in May of 2020. Some bad things were happening around that time, or so I hear. This is here is a histogram of daily flight delays from Houston Intercontinental Airport. And so this is colored by year, or separated by year, maybe is a better way to say it. Here's a better looking version of this. This is a kernel density estimation plot. And you can see that the year 2020 is really the outlier here. And the way to interpret this graph is to say, hey, 2020 had very many days that did not have a lot of delayed flights. Another way to interpret a graph like this for JFK, let's say, is, oh, the red 2022 years have been shifted to the right relative to all of these other years. And so something is happening in the year 2022 that I, the person in charge of JFK Airport, might be interested to know, like, hey, why are we having so many more flight delays now than we used to in the past? And so this is just a type of output for our pipeline that someone else can look at. They can copy it, they can steal it if they want to, although I would encourage it. Plagiarism is not a good idea. They can build off of it on their own. And so please check out our GitHub repository, and you will see all sorts of fun information in there. And now to turn it over to potential future developments and next steps, we turn it back over to Mohammed.
Thank you, Stephen. Our next steps are included but not limited to get the stakeholders' feedback and improve our system to get their satisfaction. Expand database to more airports. One of our data source is AnyFlight's website, so we should trigger API calls when data gets updated. Try to come up with more extensible SQL codes to cover more data which may come along. The goal is the SQL codes run automatically when future weather and flights data are available.
And with that, we thank you for watching this presentation. We thank you for stewarding our journey through practical data engineering over the past 7 weeks, and for your timely feedback and office hour presentations. Anything else, Mohammed or Vivian?
Thank you so much.
All right, thank you very much. And here are some references that we surely hope that you will check out and visit on your own, because these people did a really good job putting information together.
Thank you.